All right, so good morning, everybody, and welcome back to our second webinar in our four-part series on project-based learning. This series is brought to you in partnership with the Wisconsin After School Network and the Department of Public Instruction. All of these webinars will be recorded and they will be housed on the Wisconsin After School Network YouTube channel in a project-based learning playlist. So I am going to wait till all four of these webinars are complete, and then we'll populate that playlist all at once. So you can watch for that at the end of October, early November. We will also be adding a project-based learning dropdown on our website. So on the Wisconsin After School Network website under OST Resource Center, there will be a new project-based learning dropdown where we will house some of the resources that are being shared in all of these webinars throughout the series. All right, so I am going to turn it over to our two presenters today, and I will let them introduce themselves.
Good morning. So we are talking about STEM project-based learning today, and we have a slide that's going to introduce us in a minute. But I just wanted to reflect a little bit on last week when you heard about project-based learning in general. And I think one of the analogies they used was that projects, what's the difference between project-based learning and a project? And projects can be like the dessert in a learning experience. It's the culmination, it's the showcasing of what kids have learned, but project-based learning is like the main course, the whole thing. It's the structure on which you base all of the learning and how kids are engaged. But I'd also like to add that a project might be an appetizer, because just looking at the whole process of project-based learning can be a little overwhelming at first. And so just starting with a simple project can be a way to get kids used to this kind of learning and give educators a little experience in facilitating this kind of learning. So I guess I just want to encourage you to start small and build from there. So who are we? I am a STEM consultant with the Wisconsin After School Network. I've worked with STEM with educators for a number of years, both in formal education and non-formal education, doing professional development and really assisting educators in developing partnerships and ways that they can strengthen their STEM learning. Joanna.
Good morning. My name is Joanna Skazacek, and I work with the Division of Extension on the UW-Madison campus. And I am the 4-H and Positive Youth Development STEM specialist for the state.
Great. And so one thing that I guess I'll talk about this more later, but that we really want to be consultants for you beyond the professional development that we do, and really want to learn about the STEM that you're doing and learn about what you need in order to do it. So I hope that we'll all communicate beyond this workshop. This is our plan for the morning. We're going to start with getting some of your ideas for the kinds of projects that might be meaningful to you. And then we'll come back again to that at the end. I want to clarify what STEM is and what we mean by STEM, how it relates to youth development, really look at what some examples of how this looks in the real world, and then really help you get started. So last week was some of the why and the what does it look like, and really we hope to get into the how. And how do you get started with this? And how do you evaluate and celebrate it when you're able to do this kind of learning? So Joanna, I think you're going to introduce this.
So as Dolly said, that we're gonna come back to this question, but we want to prepare you for that time. So as we're going through here, I'd like you to start thinking of a problem or some sort of question in your community that might require some understanding of science, technology, engineering, or math to gain more information about the problem or actually to solve the problem. And that can be in any sort of types of discipline, whether it's food or health, arts or design. So we're going to return to this later, but as you're going through, start thinking about some projects that might be meaningful for your young people.
Great. So first of all, what do we mean by STEM? So I'm guessing many of you might already be familiar with the fact that there are next generation science standards that formal education is working with. And one of the new features of the next generation standards are the science and engineering practices. And so when we often think of STEM, we think of the content. We think of biology or chemistry or physics or what have you, and all of the content and knowledge that people need to learn. But what's really more important and perhaps more appropriate for you to emphasize in out of school time education are the way that scientists and engineers actually work. What do they actually do? It's great if you can make connections with the content that they're learning, whether it be plants or animals or force and motion. But what's really more important is how they're doing the science and developing these kinds of skills. And I want you to notice that it's not the old model that you may have learned in school of hypothesis, methods, conclusion. That's not how we're looking at the process of science anymore. It's a lot messier than that. And actually, it's a lot more interesting than that. So I want you to look at these and think about the example that you heard last week of a group of students that was investigating a playground in their community. And they were looking at the playground and thinking about the safety that people would have on that playground and the substrates under it, and just looking at the whole landscape of that playground. And they did some analysis and then they presented it to someone in the town council. And I would say that they were doing STEM. They were really using many of these processes. They were asking questions, they were carrying out an investigation. They perhaps could have made it a little more STEM oriented by measuring the height of the swings and dropping objects on different subjects and measuring the force. So they could have perhaps added more STEM to it. But even with what we saw in the video, I would say that they were doing many of these steps. And so really the process of project-based learning parallels the process of science. And so when you're doing one, you're really doing the other. And these kinds of skills can really be highlighted in after school through meaningful projects. Next. Another way to look at these is just a simple explanation that kids can understand. They might not use the words in those science processes, but they can understand if they were being curious, if they asked a question, if they made an observation. So this is something you might want to use on a daily basis with kids and just get them to think about how they are using science in all of the things that they're doing. One thing that we're talking about a lot lately is creating a STEM identity, that's really important in kids' engagement in STEM, that they see themselves as a scientist or an engineer. And as you know from working with kids, kids are scientists. They are natural scientists. They do these things all the time. And so part of our job is just to get them to recognize that and to reward them for using the processes of science.
So just to sort of continue to capitalize on what Dolly was saying, what we really are talking about is not necessarily science or art or the content. What we really want to instill in young people is this model of positive youth development. That is what we are in the business of doing. The content is sort of the hook. It can bring the kids to the table, but whether or not they are successful as scientists will depend on whether they're building these positive youth development skills and not necessarily learning the content about how to program a robot or to do some other engineering, how to build a bridge. And so there are lots of different models out there. This one is from Partners in Education and Resilience. And you can just see how, even though there are different models, we're all talking about the same thing, right? And so assertiveness, having kids ask questions, being able to choose their own direction in terms of planning, talking about belonging, that's when they share and they communicate and they feel like they've contributed, they work as a team, they reflect. So once they do all of this stuff, they do the content, it's like, well, why did I do that? So how does this relate to some other thing in my life? Or how can I use the same process to answer a different question? And of course, we want them to be active. So we want them to be making the observations. We want them to be doing the testing. We want them to be doing the thinking. And as educators, we're just facilitating that. It's not up to us to know the answer. And sometimes there's not an answer, or there's not one answer. We want the kids to be developing those questions and those solutions and that information. And so when we talk about 21st century skills, that's really what we're talking about. We're talking about young people being able to think critically, to be self-directed, to be responsible and take accountability for the information that they're gathering and sharing. And so, we want to make sure that we're focusing on those skills through the content. So we're going to show a video. And so we want to go back to the previous slide where we started thinking about a problem in your community that young people might want to investigate through some of these processes. And this is video is going to show sort of an example of that with young people. But while you're looking at this, be asking yourself some questions about what are the educators doing to make this engaging for the young people? What sort of skills are they trying to instill into these young people in terms of when they're doing the activity? And we'll come back to that in just a second. And so I will hopefully just play this video. We should. And we're not going to watch the whole video, so I'm just going to fast forward to the area that we want to focus on for today. However, if you do have time, you should go and you should check out the whole video because it is pretty neat. But I'm just going to
look at what's relevant for our students, what's happening in the world, and design a driving question.
I like it a lot because there's like one question, one big picture. I like big pictures, but I also like that you can like ask little questions within the big question.
A big standard in third grade is teaching about heat. We wanted to see if students could figure out a problem within their community that they could solve using heat. We immediately thought of a snowpocalypse. Heat played an important role, whether it was related to the weather or how Atlantans coped.
There was just coldness and snow and ice, and so heat plays a really good part to keep us warm.
We eventually arrived at the question of how can we better prepare for Atlanta's changing weather.
We went in this direction because we knew that it affected a lot of their families, it affected our school.
My students researched the event. I brought in some community members to just share their stories.
We had so many people stranded. We had students who were on the bus 10, 11 o'clock at night. And we was trying to contact parents just to let them know where their child was.
They couldn't believe some of the stuff they heard. And that, to me, was this very organic way that they arrived at this problem and this feeling of, I want to do something about it.
We are going to be thinking of some ways to help Atlantans better prepare for weather like this.
The teachers may have designed a project that's going to guide the students in a direction, but the students have a big role helping to design products that will solve those problems.
My class came up with some type of safety case that would help them if they were stranded. So they'll do certain little mini projects along the way, like a solar oven. We're gonna talk about insulation. They'll test different materials to see what are good conductors of heat and to see how could these everyday materials fit into your kit.
Wooden spoon, plastic spoon, metal spoon.
Does it feel cold? Does it feel hot?
Feel it.
Record your observations. What about the metal spoon, Destiny?
The metal spoon got hotter.
So that was the hottest?
Yes.
All right, so right
One
now.
of the questions that they said that they needed to know was, well, how is heat produced? Mr. Thomas came up with the idea to bring the entire third grade out.
Heat energy can be transferred in how many ways? 3, conduction, radiation, and convection. The heat from the sun will transfer energy to the air inside this bag. Once the molecules in the air inside the bag get warmed up, the solar bag is going to rise into the air.
Our commitment to STEAM has shaped how we do project-based learning here at Drew. Technology, science, engineering, that all factors into what we're looking for the students to be able to do when they're answering this driving question.
We see our students collaborating naturally to solve problems, not just the ones presented to them by teachers, but the ones that they just face every day.
Great. So let's talk just a little bit about what we saw in the video. And you can use your chat, you can unmute. So what did you see? What were some of the things that you thought about for project-based learning? What were the teachers doing? What were the students doing that made this an interesting project?
You can type something in the chat.
I'm gonna stop sharing for a second so I can see all of your faces. So Sam says they kept the prompt focus question really broad, allowing for lots of opportunities. Yep. What else did you see? For me, I would say that I saw that they took like this really sort of big concept, and just like the young person at the beginning of the video said, you have this really broad concept, but you can test really small things. So a simple test of using warm water, a metal spoon, and a plastic spoon, and talking to kids about why one heats up and why one doesn't. And those are the concepts that we want kids to understand through asking these questions. So that's the contents, but the kids are developing and they're trying to understand what's happening in the world around them by just focusing on this really small piece of the puzzle.
So Sam wrote, they also chose something that was relevant to the kids. They had just lived it. I don't particularly remember the snowpocalypse in Atlanta, but we've had a lot of weird weather events. So something that's really in the kids' minds. Example with the balloon about heat. The same concept in multiple ways.
Mm-hmm.
Not one way to the solution. Right. So even though there was this really big problem or really big issue, the educators were able to find, as Joanna said, some really small way that kids could learn about it and possibly contribute to solving or how to help it or help in the next time.
Great. Start sharing again. Sorry, little little problem. No problem. Shit. And so when we start talking again about this driving question, this big picture question, should be real world. This was something that the kids experienced. And it was something that these young people, being from Atlanta, didn't have a lot of experience with, right? So they don't get a lot of snow. They don't get a lot of cold. Whereas a young person from Wisconsin might have different ideas about what to explore in terms of, a big snow event. And so it's something that the kids can add to their base of knowledge and they find intriguing. So Dolly,
and so as you can see in the example, it allowed kids to be creative. Again, looking back at the old model of how you do science, hypothesis, methods, conclusion, that maybe didn't account or allow for a lot of creativity, project-based learning in STEM really does. There's a basic problem. Kids need to learn accurate information, but they can be creative in how they use that information. It's interdisciplinary. You can't look at the science alone without looking at what people are doing and social sciences and how many people need to get to work in downtown Atlanta and where are they going. And so it's really tying a lot of different things together. It's not looking at things in an isolated way. It has to be experiential. Kids have to be doing something. I thought it was really interesting in the example how they had people from the city come in and talk about the problems. So it's like they were hearing this from the people who had to make decisions and they were communicating with those people, and these were really young kids. So I thought that was really cool. And of course, inquiry based. It's not giving them information, it's having them figure it out in an interesting way. And there's nothing wrong with it being fun, and it really does need to be fun in order to engage kids. So the steps are really introducing and preparing, capturing that student voice, introducing a topic, but find out what they want to know about it, what they think about it. So I think depending on the age of your kids and where you are in your experience with project-based learning, in some cases, you might have to start by giving them a driving question just so they get the idea and they learn how to do this kind of work. Eventually, the idea would be to have kids come up with their own driving question. How's the topic connected to their life? So developing that driving question is really an important part. And then what do we need to know to answer that driving question? How can we get this information? How can we learn about it? What's our plan? What do we want to achieve? Do we have some sort of a goal or outcome we'd like to achieve? Maybe the goal in this one was making sure that there were some safety measures so that people wouldn't get stuck and be cold in the next snow apocalypse. So to have some kind of a goal. And then basically lining out a work plan. Who's going to do what? And each person needs to have a meaningful role. All the kids don't have to have exactly the same role and do the same thing. You can use kids' unique skills, but also stretch them out of their comfort zone a bit. So you might start with having kids do something that they're really good at and get some success and feel that they're contributing, and then eventually give them some tasks that maybe are a little bit out of what they're used to doing. So using those youth development skills that you use every day. Some kids can collect data, do measurements, some can write to or call resource people. Some kids can keep a journal of what you're learning about the topic. Some might construct those informational pieces, PowerPoints, or make videos, give presentations, just to make sure that all kids are engaged in some way. And then celebrating and reflecting, it can be creative. It could be a report or a presentation. It could be a plan that you present to someone. It could be a video. It could be an artistic expression of what you've learned. But really finding some way to share that in a creative way. And then evaluation, and that's a word that sometimes scares us. But if you've really thought about what you want to achieve, it's not that you're evaluating your progress or you're evaluating the kids, but that they're evaluating this for themselves. What did they accomplish? What did they learn? And so it really becomes very authentic, and they have some investment in it and want to know to what extent they were successful. And there's so many ways to share outcomes. And I think that might be in the next slide to share. Yeah, so this authentic assessment. One thing that we had done a number of times here in Madison was to create a science symposium. We had done it for middle school students who did science projects, but also elementary level students in after school programs, sharing their knowledge of what they learned in science and engaging the community in some way. So you saw the example of in the video of sharing what they had learned, but they could present this at some sort of an event, and the kids could present their ideas to decision makers. We had a partnership here in Madison with the Madison Children's Museum, and they were happy to host this STEM symposium that invited a number of after-school programs and their families and their parents, and really showcased what they've learned and made them feel like they were real scientists. And they were.
I think one thing I'll just add to that is we all are here because we do out of school time programming, and out of school time programming and after school program is really a great place to do project-based and inquiry-based learning, because you don't have the additional structure and pressure of that examination at the end. And that's how you assess. And that's how, classes, for good or for bad, how classes are normally assessed in formal education. You give young people an exam and they are given a score. And after school, we have different ways to understand if kids are learning. We can observe, we can have them share, and they learn as much by not doing things right or having some failing forward, as we call it. And they learn a lot through that process, even if their experiments don't work, or even if they don't necessarily get to the endpoint they were expecting. And that's the way real science happens in the world. If it was easy and straightforward, everyone would do it and it wouldn't be any fun. So having kids really just be able to be themselves and bring themselves to the project, and observing that is a great way to, assess whether you're being successful.
Right. And that reflection is really a simple process. It's basically asking questions like, what did we do really well? What did we accomplish? What did we do really well? What was challenging for us? What was hard about this? And could we have done something differently? What would we do next time? And so just asking some of those simple questions can really lead to that more authentic assessment.
So, as I mentioned a couple of times, we're going to be returning to this driving question. What's really great about these sort of professional development opportunities is we want you all to engage with each other, because Dolly and I, we have our ideas about how this might move forward, but really your peers and the other people in this room are the ones that really have some great ideas. And so we're going to spend a little bit of time on this, and we're going to ask you to be engaged with this process. And so think about that driving question that we asked you to think about earlier. What sort of things, what sort of topics do you think that your young people that you work with would want to know a little bit more about, or a question that might want to be solved. And we're actually going to have you write this down. And so you can write it in the chat, or you can write it on a piece of paper, and then you can, at some point, we're going to share, and we're going to have, you can unmute and just read what you had written. So we're just going to I'm going to stop talking, and you're going to take maybe 1 minute or so. It might seem like a long time, but it's not. To write down your thoughts about a driving question or a few different driving questions, and then we're going to share them with each other.
And I just want to say, it doesn't need to be as big a question as the snowpocalypse in Atlanta and what to do about it. It could just be something that your kids are interested in and that they might want to explore more, and putting that into a question. So it doesn't have to be a big, world or even community problem, just anything that they might be wondering about.
So while you're writing that down, think about what you need to know in order to answer, what the young people might need to know to answer that question or find out more information about that question. And then if you can think of some activities that you've done or that might be fun or that you saw in the video that would be useful in helping kids get more information about their driving questions.
And you're welcome to start typing in the chat if you have a question.
I'm just going to come off of mute and talk about it.
Great.
So when you first presented the question, something that came to my mind right away. So I was on a bike ride yesterday, and one thing that I really value about our community is that we have pretty ample bike paths and pretty well marked bike lanes. But there's one spot on my ride where we have a bike lane, and without warning, it just disappears and it becomes like the median of the road. And I was like, wow, like I have a lot of kids that bike, and like that to me is a problem that needs solving. And as we went further, I realized like, no, that's a really that's far too specific. So I started thinking a little bit broader, and my thought was like, how can we make our community a better place for bicyclists? And then I realized like, you're still narrowing it. Like, why don't we go further and say like, how can we make our community a place that's easier to get around in? And like how many more options for exploration that brought in. Because then you can be talking about bike paths, but you can also be talking about sidewalks, and we can be talking about general accessibility. And now we're talking about ramps and physics and all kinds of good things.
And that phrasing the question like that brings all the young people into the conversation, right? So even if they don't ride, they might not ride their bicycle, and they're like, well, I don't care about that. But they probably all do walk on the sidewalk at some point, right? They probably do use the doors to the building, and if they're not handicap accessible, what does that mean? And so that's really a great example.
Right, and I would say there's advantages and disadvantages to being broad or narrow, and depending on the kids and how easy it is to engage them and the educators, you might want to start with that one very narrow example and seeing how they might solve that, and then going to the broad one. But whatever works for you, either is a very valid project.
And so I'm seeing in the chat, how can we best connect our elderly neighbors at Oak Grove Assisted Living? So if there's young people who want to connect more with these elderly folks, and have them generate ways by understanding their community that they're working with and generating some ideas. It's great.
Linda, do you have thoughts about that you'd like to share, or what they might need to know in order to answer that question?
I may or may not keep a connection here. I don't have very good connection for whatever reason, so I apologize if I lose you. This has been a question that our kids came up with early this year. We already meet with the Oak Grove Assisted Living residents once a month, and we do bingo, and it's a very short time frame. We talk about why is this important? How do we? What is it that is gained on both ends, and how can we best capitalize on our time together? Because right now what's happened is that when we go to visit with these residents, we can only be there, we only have about 40 minutes of time, and then they start their dinner. so we need a deeper conversation to figure out, well, how can we add time to this, and what can we do to capitalize on that time, maybe during the dinner and et cetera. So we've started conversations around this piece.
Great.
And when there are challenges like that, it really leaves you open to creativity. They have to come up with some sort of creative solution. And yeah, that's a great example. How can we help keep our community cleaner? Nicole, do you have any thoughts about that one, and what activities and what kinds of science knowledge they might need to have in order to do that one? Maybe Nicole doesn't have a good enough connection. But I could think of a number of things there. Just thinking about, I'm not sure, there's a lot of ways you can look at clean, whether it's just garbage or if it's the water, or, there's so many aspects of a community being clean. Looking at recycling, what does your community recycle, and having them analyze that. Looking at the water quality. There's so many aspects to keeping your community cleaner that kids could investigate.
And it could just, the community could be their school. And so maybe thinking about in school, are there some trash problems? I mean, where are the trash bins located? Are they located in a place that they're being used? Are they being emptied often enough? Or are they overflowing? And, kids can gather more information and develop a plan and say, well, we realized that we didn't have the trash cans in areas that the kids really need to have trash cans. And so, and that's, you can make it as large or as small as you want and as the kids want.
And really analyzing what the trash is and what kinds of things people are using and kids are using, and are we bringing our lunch in reusable containers versus disposable containers, and maybe getting the school community to change the way that they do things, and change families' habits in packing lunches or things like that. So there's lots of potential there. Board games, fun as engaging as video games. I like that one, just less time. So please feel free to jump in, any of you, with ideas of to expand on your question.
Caslin's comment on the video games made me think about a constant debate that our kids want to engage in is whether or not video games or technology are ultimately more harmful or more hurtful or more helpful. And I think that would be, that's a really, really big and broad, but would certainly be engaging.
Yeah. And it's something that lots of people are interested in, right? And so parents are really interested in that. And so, the kids are really doing something meaningful that they can share with others, because it is a valid debate. right? So educational technology versus video games, and what benefits they have to young people, and sometimes what harms they have to young people. As we were watching the video, I was actually thinking a little bit more about sort of this, you know, a snowstorm or something. And, you know, one of the concepts that we try to let young people learn about are the phases of matter, right? So ice, water, and steam. And so thinking about, well, you know, why was ice a problem? Well, you know, it's slippery. Well, what do we do to melt ice? We put something on it. Well, what's that something, and how does that something work? And then, you know, what is the temperature, right? Thinking about temperature. So at this temperature, this is when liquid water goes to ice, and that's, you know, really dangerous temperature. You know, different things like that, which you can have some really simple experiments, and they can be learning about a really big concept.
And I think just really listening to kids' questions is a really important skill. Sometimes kids are asking so many questions that we just tune them out. And it's really important to listen to them. And so many of them, once you get into this process, can really lead to more of these important driving questions that could really motivate them to learn about new things. Anyone else have an example to share, or like to talk about a question that they might want to explore in their community?
What I would encourage you to do is as you're thinking about this, you know, reach out to, you know, folks like Dolly and I, and other people at One, and your other peers on this call. As I said, that's a really important part of this learning process. I mean, we're all learning how to do science and technology with young people better and better all the time. And so, you know, as you're thinking about these things, you might kind of get stuck. You might say, gosh, you know, I don't know how that might play out in my particular classroom. And that's when you should reach out and say, you know, I was thinking about this. Can we just talk a little bit more about how this might look in the classroom, or what experiments or what resources you might have around these things? Because that's really where Dolly and I can help. If you have these concepts, we can help find resources, and we're going to be talking about resources in just a minute. And so I just wanted to you know, let you know that that's, you know, why we're here. We all want to try to do STEM better in the classroom.
So there are a lot of resources out there, and you do not need to reinvent the wheel. So the last couple of years, there's been something called the State Inquiry Experience, and it was all about water quality. And on this website, it's a collaboration between DPI and a number of other environmental organizations and DNR, to have kids look at water in their community and contribute that to a database. And so this would be one easy way to get started, and one kind of project that's all laid out for you to experiment with this. And you could go beyond it to look at other water issues in your community. There are a lot of examples of citizen science opportunities that we really could expand on this whole idea of project-based learning that can get kids looking at their environment in their community and contributing to a larger database of knowledge, and collaborating with other students and even other adults. And that might be down the road, but there are just so many opportunities to use this to really make a difference. Science Buddies is one website that just has a lot of different science projects. that, as I said, might be your appetizer to just getting started in project-based learning by just doing some simple projects and getting kids used to the idea that they can find the answer to a question and they can do some of these things themselves. The organization that I worked for at UW-Madison developed its Adult Role Models in Science, ARMS, a wiki that has a Google site with a lot of different science activities on different topics. So you can look at activities related to plants, activities related to animals, activities related to engineering, physical science. So, and for science buddies, they're listed that way as well. So when you're exploring a specific topic, you'll be able to find some activities there. But as Joanna said, you can also come to us and we might just be able to send you a few off the top of our head. PBL Works is another really great website. You do need to register in order to get into some of the resources, but there's no cost to it. And they have a lot of frameworks for how to get started in project-based learning and some laid out sort of units that you can use. And I'll show you one, I think, in the next slide. U for Youth is another one that has a lot of templates and resources to get started with project-based learning. And Joanna, did you want to mention the 4-H resource?
Sure, yeah, and watching our time, so we have some time to share a little bit. So so as I mentioned before, I'm part of the Division of Extension, and a lot of things that I do, I work with 4-H a lot. And so one thing about 4-H is it's the largest youth development organization in the country. And so we have this sort of large scale national umbrella. However, in every county, we have a 4-H or a positive youth development educator. And that is really the connection that I want to help you make. In your communities, there are other people trying to do the same thing that you're trying to do. And so the educator in your county or in your community that works with 4-H or positive youth development with the university, one of their roles is to help you identify resources, to help you understand the community that you're working with, so that when you implement project-based learning, which 4-H is all about project-based and informal education, that you have some tools that will help you do that. And so I encourage you to go to the website. You can also go to the Wisconsin 4-H website, and you'll find lots of useful information.
Yeah, this is just one example from PBL Works. And so these are the kinds of units, and it can be as simple as this: kitchen chemists. What's the chemistry behind the recipes we create? It doesn't sound like a big problem, a big issue to solve, but it's something to get kids into learning around a certain topic and answering a question. And so it gives you specific activities and specific content that you can explore. So I'd really encourage you to explore that website.
And, a lot of different topics go into that big picture, right? And so you see some of it here: states of matter. Why does sugar dissolve in water? What are the properties of things that make it taste the way that they do? How do we mix things together effectively? All sorts of science and technology and chemistry in baking and cooking, and it's usually pretty fun for kids. So, that's a really good example. So we want to have a little time for you to ask questions and things. So
this is the STEM team from the Wisconsin After School Network. This year we have several consultants that are working with us, just real part-time, but that can help you get some of this going. You've met me. Bernie used to work for Edgewood College and really has a lot to offer in family engagement and engaging parents in science. Kristen is the president of the Wisconsin Society of Science Teachers and is a high school physics teacher, and really looking at more the school to work transition, and also expertise in physical science. Kelly and Shaheen both are DOS observers, and so they can come into your program and do some of these observations to help you document the science engagement of your kids and help you learn how to really evaluate your program. And that can contribute to all of our data that we're keeping here in Wisconsin about STEM engagement for kids. So I would encourage you to ask for their help as well. So we really want to know what you need in order to do this and how we can help you. And so really in these last few minutes, we really want to hear from you about, gee, does this sound like something you can do in your program? Does this sound like something that is great, but boy, I don't know where to get started? What can we do to help you? Any thoughts? How will I'm assuming many of you are in more of a director or supervisor role. How can you share this with your staff so that they're capable and comfortable doing this kind of learning? Any thoughts, either chat or you can unmute yourself.
Hello.
Yes.
This is Allison from Reedsburg. I don't know if it will still keep working, my connection. But anyway, I guess I've been under the impression that it needs to be so student driven. Like the students have to come up with the question and this, everything. And that's been really hard since I have elementary kids. So that's what's been really hard. And we've been trying to do that. We survey them and then we try to get them going and we try to get them to come up with questions. So that's I guess my big confusion is how much we can lead on it.
I think that's the ideal and the ultimate goal. But I don't think you can start there. I don't think it's realistic for most people to start there. If you've got kids that have burning questions, great, go with it. But you might need to give them a question, and just by knowing something that they're interested in, like the kitchen chemistry, like that's not some big problem or driving question, but it's a way to get started exploring a topic. And I think it's fine to start with something like that. And so, yes, you can do project-based learning by helping guide the students to a question. Joanna, do you have thoughts too?
Yeah, I think what you're saying is correct, Dolly. So when we work with young people, and especially elementary school students, they don't know how to ask these questions yet, right? So part of our job is to help them understand how to sort of generate those sort of questions. They don't know how to do it organically because they've just been trained sort of in the formal classroom where in many cases they're being directed, very carefully and very closely. And so it's about starting to give them that freedom. And like Dolly said, it's not something that you're just going to like start with that right away, because and as educators, I mean, lots of times we're fairly inexperienced with leading and facilitating those sorts of questions. And so it's up to us to sort of be able to facilitate those conversations and help the young people learn how to start asking some of those questions.
That was a great question, Allison. Do any of the others of you have insights about that to contribute? Because maybe you've had experience trying to get kids to ask questions as well.
I think that this is kind of like a duh. Anybody who works with kids kind of knows it, but something that when you get really invested in a project, sometimes like your dream is there and you're like, oh, I'm going to go with this and this is going to be great. But part of this work is also like recognizing when it's not interesting to the kids anymore. And like, you're just like, all right, well, like this one didn't work and that's okay. And it's not going to deter me from like you know, if this lasted this long, awesome. Next time we'll try and get something that lasts a little bit longer, that it's, you know, ending a project where you didn't expect it to go is not an example of failure, you know, like that's the whole point of this, is that it is very experiential and it's led on its own. And if that means that it just kind of stops at the end of some of them, like that's okay.
Exactly. Yeah, kids need practice with the process before they can really do it on their own. And so I think starting with something that's really guided by the educator, then gradually moving into something that's more student driven. Other comments about that or other questions in our last few minutes?
I see the using I wonder statements, and that's a great way. I wonder why this is happening. I wonder what that is.
Right. And we'll be talking more about driving questions, and giving you some resources on that. And also this leads into our last session that's going to be in 2 weeks on partnerships. And so sometimes you may not be able to do all this on your own. What are some community organizations and other experts in your community and in the state that you can lean on to be able to help you either generate questions, find activities, and get kids engaged in real world science?
All right, with our last 2 minutes, unless there are any other questions, I think I will wrap us up. Is that okay, Joanna and Dolly?
Sounds great.
Awesome. All right, so I did put in the chat, if you do have questions, you can email the Wisconsin After School Network and we will get you connected with all the people that Dolly and Joanna mentioned on their slide. You can also visit the website if you're looking for some other STEM resources. And Dolly is going to be facilitating an Asking Purposeful Questions training in November, kind of related to this. And you can find that in the events on our website if you are interested in exploring a little bit more about how you can ask those questions of young people in your programs. So again, a quick reminder, these are recorded. We will be housing all of them on the YouTube channel. And before you leave, we do have another evaluation poll. So I am going to ask you to take just a minute to complete that. And when you are done, you may head out. So we hope you have an amazing rest of the day. Thanks again for joining us.
Thank you so much.